In question 12, we've been asked to find the horizontal distance between the bottom of a cliff, which is 100 metres high, and a buoy on the surface of the sea, and the angle of elevation between that buoy and the top of the cliff is 20 degrees. As the angle between the sea and the cliff is a right angle, we can use SOH CAH TOA. And what relationship is it? Well, if we're this angle, we look out, we've got an opposite and we've got an adjacent. O and A, TOA, it's tan. So therefore I can say tan 20 degrees is equal to the opposite, which is 100, divided by D. Moving things around, D is equal to 100 divided by tan 20. And if you pop that into a calculator, you get 274.747 metres, which to three significant figures, doing the cut here, is 275 metres, and that's to three significant figures. And that's your answer. Okay, in part B, we're told that there's a radio mast on the top of the cliff, and the angle of elevation from the same point B, the buoy on the surface of the sea, up to the top of the thing is 25 degrees. And we're asked to calculate the height of the radio mast. Let's call this H. Okay, so the angle of 25 degrees must have an opposite now of H plus 100. We've got the adjacent, we now know the adjacent, at 274.747 metres. So I can set up an equation with 25 and the 100 plus H, the relationship being, again, opposite over adjacent, which is tan. Don't use the rounded up figure, use the accurate result. So therefore, multiplying across, H plus 100 is equal to tan 25 multiplied by 274.747. Working this out and then subtracting 100 from it, we get, therefore, H is equal to 28.1169 metres. And if we want three significant figures, there's the cutoff point, and therefore H is equal to 28.1 metres, and that is to three significant figures. And that's the result.